Okay, so welcome to another video, which is going to be about a parallel study plan that we are still doing, which is dynamic programming. This is the second problem in that study plan, which is nth Tribonacci number. Tribonacci is similar to Fibonacci, where in Fibonacci we take the sum of previous two numbers that we have seen in the um, array or in the list. Here we sum up the last three that we have seen. So what it means is let me get my whiteboard and I'll just show you. So this is was the fib, okay? Let me put this on side. Tribonacci sequence. So it says take T0 equal to 0, T1 equal to 1, T2 equal to 1. Okay, that is pretty clear. This is also 1. This will be our base conditions. So if you haven't seen the video for Fibonacci, it's a good idea to check that out because it's exactly related to that. It has been asked in Apple, Adobe, and Amazon. Okay, so for n greater than equal to 0, it says, so this is only valid for T3 and onwards. T3 is equal to T2 plus T1 plus T0 and so on for all n greater than or equal to 0. So the expression is okay. This is the expression. So here, so n is given as 4 in the example. So T4 will be T3 plus T2 plus T1. T2 and T1 we already know have been given the value 1 plus 1. T3 we can calculate from here, which will be T4 is 4, as you can see. Okay. So answer is guaranteed to fit within 32-bit integer. Okay. So what we will do is we'll first we will write memoization is nothing but if we go back to the previous example, so we found that fib of n minus 2 and fib of these two were getting called again and again. Okay, so what our idea was just to store it in some kind of store. So that storing this action is called memoization. Storing it in some array or something, some memory location. Okay, so that is called memoization. So that's what I am trying to talk about here. So let's start with writing the basic recursive code. That shouldn't be much difficult. Okay. like always, here we will start with the base condition because it's a recursive code, so we should know what our base conditions are. So initialize, no, if n is equal to 0, we return 0. If n is equal to 1 or n is equal to 2, we return 1. These are the base conditions. Now with that out of the way, to calculate further Tribonacci numbers, Tribonacci of n minus 2, n minus 1, n. Okay, so why we are getting this n minus 2 and all those things from this expression? It's directly coming from this n plus 3, n plus 2 expression. Okay, so here we can turn this expression. So what if n plus 3 was n? Then this would have become n minus 2, n minus 1 plus tn. Should be clear to. So let's take m here. Okay, so n is equal to m minus 3. Let's substitute the value of n in the terms of m. So Tm is equal to Tm minus 1 plus, got it? So this is the expression that I'm trying to use here. There is a mistake that I've done that I need to correct. It should be n minus 3 according to the expression, which is this one. Okay, let's try to run it. So see, it is working, and it is working for n equal to 25 as well. Let's try to give 37. See the amount of time. See, we got TLE. This is why it is important. You cannot just write a recursive code every time. In Fibonacci it worked, but in Tribonacci it won't work because there is the tree. In this case, let me show that how the recursive tree will look like. We can take an example of fib of 6. Okay, and so on for this also. Similarly for this also. So the tree is much more denser and it requires a lot more repetitive calculations. So that is why that time limit exceeded error came up. So we will try to optimize it again in the manner that we did in Fibonacci. Let's go to the Fibonacci. Yeah, so where we were also maintaining an array. So we'll do the same thing here as well. Let's call trip. Now we will trip 0 is 0, trip 1 is 1, trip 2 is 1. Okay. Now for all n from 3 starting onwards, greater than equal to n, what we will do is we will store the trip value trip I minus 1 plus trip I minus 2 plus trip I minus 3 and just return trip of n value here. See, it is working for even 37 as well. So we can submit it this case. Uh, Here we are doing nothing, but it's the similar optimization as compared to Fibonacci, okay? Where we are storing all the values that we are building. So this is called bottom-up approach because we are starting with the the smallest values of n that are possible, and then we are just trying to build the solution out of it. And that's what we get at the end, trip of n, okay? Let's submit it. So it's a decent enough solution, and yeah, you can see that it's beating 91% even in space. But space complexity is O of n here. Time complexity is anyway O of n, but space complexity is also O of n. So again, we can try to optimize it further, just like we did in fib of n, a Fibonacci sequence. Okay, so we can see we don't, while calculating, we only require the previous three values that we have seen. We are not concerned with any other values. So just to give you another example, 0, 1, 1, 2, 4, 7, 13. So when we were calculating 13, we were only concerned with these three values and not with these previous ones. So that's the idea that we can use to optimize the space complexity in this case. Let's get rid of this and maintain three variables, n minus 1, n minus 2 will be 0, n minus 1, sorry, it should be 1. Okay. So for every stage, we will sum up the three previous values that we have seen. So 0, 1, 1 will be summed up in this case. Okay. So for calculating n equal to 4, we, for example, we take 1, 1 and 2. So those three values will be stored here. Okay. Now we just have to be very smart about changing these values over the for loop. So in the next iteration of for loop, what will happen is n minus 1 will be trib of n in that case. N minus 2 will be, sorry, it should be stored reverse. N minus 3 will become n minus 2. N minus 2 will become n minus 1. And n minus 1 will be trib of n. And the strip of n will be returned here. What are these errors? Let's try to resolve them. So see, it is working. What we are doing is n minus 3, n minus 2, n minus 1 summed up together will give a some trib, okay, which is trib of I, let's say, okay, trib of I, let's say. From the next I onwards, n minus 3 will become n minus 2, okay. This n minus 2 will be becoming n minus 3 for the next element. N minus 1 will be becoming n minus 2. This will not be useful anymore. And n minus 1 will be this one, which is the previous value that we have calculated. And so on. At the end, the strip of n value will be returning us the final Tribonacci number for n. So if we submit it, we will see that space complexity should also improve in this case. So it's saying 40.4. So it's not much improved over the array solution, the bottom of DP solution, but it's good enough actually. So this is just one of the approach that I wanted to share. But I always like this one, which is let me go to my submissions. I like this solution. It looks much more elegant and yeah, better. So I always like this kind of solution, which is the bottom of DP. You can write it top down as well, but I won't cover that. Otherwise, the video will become much longer. So you can come up with any bottom up or the top down approach. So the naming convention is very, very straightforward. Bottom up just means that we start with the lower end or the smallest values of n possible, and we try to build the solution towards n. going from 0 to n. In top down, what we do is we try to we start with n and we try to dig, go to the values which are smaller, which is one, zeros, and all those things, and we try to build our solution top down way. Okay, so that's all I wanted to cover in this Tribonacci number video. It's a very easy and very famous problem. That's why it's marked as easy as well. But it is a problem that gets you started with dynamic programming. So it's very important to cover these two problems, Fibonacci and Tribonacci. So that's all. I hope this was helpful. See you in the next video.